Hey guys, my name is Avinash Lakshman, founder CEO of Hedvig, and first off, thanks a lot for hosting us, Baba, and also for you guys coming to listen to what we have to share today. Right? I founded Hedvig in June of 2012, almost 3 years ago. Prior to Hedvig, I spent about 6 to 8 years building and operating large-scale distributed systems for 2 of the biggest internet properties in the world. I was at Amazon between 2004 and 2007, where I co-invented Amazon Dynamo, which went on to become the genesis for the entire NoSQL movement. And then early 2007, I joined Facebook, where Apache Cassandra was my brainchild. So these were the 2 big systems that I had the privilege and the opportunity to build and also run and operate them in a production environment. So June 2012, I founded Hedvig because there was a lot of activity I thought was very interesting at the cusp of cloud virtualization and storage. And I felt, having the unique skills that I had garnered, having built the systems that I built, that something fundamental could be done in the storage space. And that's what I tried to do, and that's where we are today. So what I'm going to let Rob do now is take over, walk you guys through a set of slides, and then I can whiteboard the idea out to a reasonable detail, and then we have a demo that will follow it up, so you guys can wrap your heads around the entire solution. Cool?
Excellent. All right, well, thank you, everybody. Just to echo Avinash's thoughts, we appreciate you guys coming out and listening to the story. I'll spend about 25-30 minutes kind of going through some slides, some of the concepts that are best done in visual, but really the meat of it will be Avinash at the whiteboard. If you ask an easy question, I'll answer it now. If you ask a hard question, I'll defer until he's at the whiteboard. So that makes sense. And then we are going to do a demo. It will be a live demo, right? So it'll be interesting to see how that all goes. And we'll even at one point pass around a mobile phone. Since the entire UI is responsive, you can actually do some live check-ins on the demo that Suresh will give via the same device logged into the same cluster. So any questions yet? That's a good sign. All right, so I'm just going to start with a little bit of the basics, just to kind of level set. I know you guys know the industry, so I'm not going to try to get into a lot of trends and build up, but instead just give you a little bit of our philosophy and our take, and some of the level setting for what you'll hear in a more technical depth. So one of the things that we see is that there is a lot of push towards business innovation driving the front end of the IT agenda, right? So the need to use technology to get in front of customers, to engage customers differently, to enter new markets, et cetera, et cetera. What we know is that is then putting a lot of pressure on time to market for new services, and it's kind of given a little bit of a renaissance to developers to help build those services. What's interesting, given Avinash's background, is that those developers are getting more and more comfortable directly interfacing with infrastructure, at least in provisioning it, right? And we can thank Amazon Web Services for a lot of this. But what we know is that the requirement, if you follow the logic chain, is that infrastructure just be more flexible. I'll be honest, most customers don't care if it's hardware defined, if it's software defined, if it's a lemonade stand. They just want the infrastructure to change a little bit more easily and adapt to new projects, new requirements. And so that was really sort of the vision and the opportunity that was before us when we set out to think about how would you do storage in this new era. And so what we find is that storage has become a significant bottleneck for a lot of companies who are trying to think of new service, who are trying to get a lot of value out of their data. Right? And that even within the new approaches to storage, arguably the software-defined approaches, they're still presenting bottlenecks. They're still presenting issues. It could be a performance issue. It could be that it lacks a certain feature. It could be that it doesn't scale appropriately. So even though this is an emerging category and it's a crowded category, and we very much acknowledge that, we still think there's an opportunity to raise the bar a little bit. And hopefully at the end we can gauge your take on whether we achieve that. So I'm just going to give you a couple of thoughts. So first of all, obviously we think software-defined storage is the right direction. So if nothing else, Hedvig is a software-defined storage solution, right? We do not sell hardware. We are a software-only company. And we think that's the right direction. We do think that companies, especially companies that are predisposed towards this innovation bent, are much more comfortable procuring hardware and putting software infrastructure on it. We also think that in this world of storage, hyperconvergence is valid, but it's valid for certain workloads, for certain use cases. Therefore, as I like to say, it's an answer, it's not the answer, right? And so in our world, we support a hyperconverged deployment mode. We also support a non-hyperconverged, or what we call hyperscale. And I'll show these diagrammatically in a second. But part of it is flexibility and choice. So you can actually deploy it in multiple ways based on the workload needs. Two more. So if you buy that with all of this move towards flexible infrastructure, there's a couple of core tenets: scalability, flexibility, self-service automation, arguably the things that make something a cloud as opposed to just a virtualized environment. What we feel is that these are ultimately distributed systems problems that need solving. So I'm going to reiterate Avinash's background in a second, but it comes from that system and that thinking so that we can build these next-gen distributed platforms. And ultimately, that approach is needed in order to bring software to parity with what was available in the hardware world, right? So storage hardware, which is very mature, very featureful, isn't flexible enough, but it has a lot of the capabilities. How do we achieve the parity on the feature front, but still ensure the flexibility? And that is ultimately a distributed systems approach. We'll talk about it in a bit more depth. Believe it or not, that's my entire wind-up. I will do no more winding up. A little bit about who we are. Avinash said this, but I always think of visuals helpful. So to reiterate, he built two large NoSQL platforms in his background. Dynamo, which not to be confused with DynamoDB, but Dynamo, which underpins the shopping cart, and Cassandra, Apache Cassandra. I think everyone knows Cassandra fairly well. It is not appropriate to think of Hedvig as a NoSQL platform, nor are we a successor to these platforms. Instead, it's taking that 10 years of building and operating a distributed system and how to think of differently about data that was brought over to the thinking of Hedvig. But this is a general purpose storage platform. It is lower in the stack, right? So it can accommodate all the different workload types. It is not a NoSQL built for certain types of web applications. So there are some similarities, but pretty much all the modern storage platforms are using concepts like this in terms of how they do the data, how do they do the metadata, how do we do the distributed algorithms, right? So a lot of that thinking went in, but one of the most common questions we get is, well, where's Cassandra in your product? You won't really find it. We're not a natural extension of Cassandra. It's actually its own net new platform, but instead built on the experience. And if you caught it, what Avinash would reiterate is that it's the operating these systems at scale inside of Facebook and Amazon where you really learn how to do some of this stuff, right? To operate things at dozens, hundreds, and even thousands of nodes. We have $12.5 million in funding to date. You can see the investors here. And we were formally founded in 2012. We launched the company out of stealth March 25th, just a few short weeks ago. And we are in GA, right? So we have a limited GA in that, we're still a small company. We're making sure we take on a reasonable set of customers. And then we'll open up, come one, come all, come big, come small, in this quarter. All right. So the one last thing I just wanted to talk about is a little bit of a level setting, because I know not all of you guys are pure storage people by background. So this is my attempt to boil 40 years of storage onto one slide. What we've seen, and this is not a mathematical equation, so if you're trying to plot the trajectory, it's probably not 100% accurate. But what we'll see is that there was a clear improvement in price performance. The cost per gigabit was going down and IOPS were going up as storage began to innovate. And we went through various architectural buckets. And we could argue whether these are the exact buckets, but we went from traditional monolithic arrays to kind of scale up arrays to scale out arrays. And somewhere in this was a little bit of an inflection point where we began to see distributed systems, and we kind of went to the hyper-converged model. And so this last gray dot really represents what a lot of the modern storage platforms are today, whether they are software-defined or appliance-based or whatever. They have some of the same principles we do, built on commodity infrastructure, using some capabilities, but what we find is that there is an opportunity to take it a level higher. And so some of the characteristics, I'm sort of a classic before and after, is that we're going from a world where it was either hardware and software tightly coupled together, or it was hardware You can choose from 6 commodity vendors and we'll give you our software on top. What we now see though is a proper software-defined storage should run on any hardware, it is software only, and it should run in any cloud. If it's truly hardware agnostic, then it can run in a cloud as easily as it can run on an x86, or as I'll talk about in a second, or on ARM. So that's one thing. It's elastic in nature, which may be a subtle distinction, but we consider that different than scale out, right? The ability to actually have the nature of a cloud scale out and scale back in, or scale up and down. Another thing that's important is our platform doesn't have any RAID in it. We use distributed algorithms in different ways. You can almost think of it as a soft RAID or a distributed RAID that allows us to do data protection using a replication methodology. And Avinash will go into this in a lot more depth. And then as I mentioned before, it isn't a model of saying it needs to be hyper-converged, but rather the ability to choose and even mix and match different types of deployments within the same cluster so that you can configure it based on what the application needs or what the workload needs. So that's all on the basics, right? So a little bit on the features. So again, I'm going to be sort of unabashedly storagey for a second just to kind of get the capabilities of the platform out there, but we will net it out. So it never ceases to amaze me that we still need a very simple equation for what exactly this is. You take an x86 or ARM commodity server, preferably one packed with lots of disk, and our software deploys on that. So we can deploy bare metal. You don't put Linux between us and the server. We're our own contained things. We run bare metal on that commodity server, and we transform each of those nodes, our servers, into a node in our kind of scale out or elastic cluster, right? So that's the basic formula. I'll talk a little bit about how hyperconverged and hyperscale, which is sort of common in it. What we've noticed is within data-specific use cases, hyperconverged is not always the best. You would go with a more traditional hyperscale, what we would call it. Think of it as a traditional storage SAN architecture, but it's now completely elastic in nature underneath. So just a couple of capabilities. It's highly scalable, right? What we could tell you is you're going to bump into operational issues on the scale side far before you bump into software limitations, meaning if you're operating nodes above 1,000 clusters, the probability and failure rates are going to nip you well before whether you're adding 1,000, 1, 2, 3. So this thing can go scale very, very high. One thing that's unique about us is we provide all the various storage flavors, block, file, and object, specifically for those who want to follow along at home. Today it's iSCSI, it's NFS. We do have SMB coming very shortly. And then on the object, S3 and Swift. What's important is all those are first-class citizens in the platform, if you will. So they're all native. We're not one of those things underneath. We're not an object store architecture that then emulates block and file, for example. We do all of those. And that's critical because as new workloads come out and as some data workloads come out that are expecting a particular type, it allows us to plug in and accommodate that with having to deploy a different island of storage to manage that data, right? And so I won't go so far as to touch on the data lake, I think, Karen, because you don't like that term very much, right? But the idea is this is one data platform, and then there's various ways to access it, as opposed to having to deploy different islands or silos. We'll get into a little bit more of the feature function, but to keep things moving along, we have everything you'd expect in a storage platform. One thing that's also a little bit unique about us.
Sorry, Rob. Quick question. You said you deploy directly to the commodity out to the hardware, right?
Yes.
Without Linux.
We have our own.
Oh, you have your own distro.
Yes.
Okay, so you're not sitting down.
Meaning we're not you don't figure out your own distro of Linux and then put us on top.
Oh, okay.
We're bare metal.
Okay, cool.
Right on. Yeah. Another thing that's a bit unique, and I'll get into the architecture, is we support a wide variety of application and compute environments that can consume us as storage. So Hyper-V, vSphere, Xen, KVM, we have Docker support, we do OpenStack integration. So again, pretty much anything that happens at the application tier, however you are choosing to deploy your application and data set, is pretty comfortable that we can fit into that environment without having to do it. Again, just to juxtapose it to other solutions where they're typically tied to a particular hypervisor or OS environment. There's some architectural choices that we can get into that we made.
You mentioned OpenStack a few times and Swift on the previous slide about interfaces. Is that a drive that's coming from within the company, or is that a demand coming from your customers?
Both. both.
So you are seeing real requests for
Yes.
OpenStack.
Yes, we are. It's funny you asked that question because just today morning, I got a call from our sales guy that we have 2 OpenStack deployments coming up. So it's good we were prepared.
Yep. Yeah, absolutely. Good.
And I can tell you from one early customer conversation, part of the reason why OpenStack was sort of confined to test and dev for them is because they didn't have some of the capabilities they needed in a production environment, specifically snaps and clones. Their IT ops guys took one look at it and threw up on it and said, this just doesn't fit into our data center operations. So I think there's a little bit of a maturation we see around OpenStack in
Which
particular.
hopefully we'll see next week.
Yes.
Yeah.
Yeah. I'm looking forward to it. I'll be up in Vancouver.
Yeah, I'm going up tomorrow.
Yeah. Okay, so these are sort of the 7. This is as techie as I'll get because I want to make sure we get on to how this thing works and how it acts as a platform. So I'll just kind of bullet out a little bit more, and then I promise we'll be done with the feature function stuff. So first of all, I've mentioned this a couple times, but we run on both x86 or ARM. I won't lie to you, we don't see any demand for ARM yet. We don't have any deployments on ARM yet. But it was one of those day zero architectural choices we had to make. There's a not too distant future where ARM plus Flash could make for very potent, low power. And again, think of us, we're a distributed system, so we want to parallelize across as many nodes as possible, right? So there's architectures that are on the horizon that we wanted to make sure that we could grow into with customers as much as support today.
Oh, sorry, Rob. Sure. A couple of quick questions. Geez, my brain went into slow-mo. What's the product called? Just Hedvig as well?
The Hedvig distributed storage platform.
Oh, okay, cool. Just want to make sure I'm cool on that. Thanks.
So with all, you'll do everything, is what it sounds like. What kinds of workloads are you seeing people use it for today? We've had questions from other people on Twitter around often other people who say, yes, we'll do everything, or yeah, we can, it's a unified storage system. But they'll be better at one thing than another, either through experience or through heritage and so on. So can you give us what information do you have to?
Yeah, I'll have a specific slide on the use cases that we're targeting where we've seen early traction that we think are sweet spots.
Oh, okay.
So I can get
we
to
can,
that.
we can
But it's
cover
a
it
fair
later
question.
if you like. Yeah.
Yeah. So I think what you're trying to tell me is speed up. Is that? No, I'm just kidding.
Not necessarily.
No, it's a good one. We'll get to that in a minute. So we talk about consolidating on the protocols, the different storage flavors that you see there. We've talked about supporting hyperconversion, hyperscale. We'll talk about that a second architecturally. There's actually 2 components to the software that I'll show you, and one of the components can run in a Docker container or as a VM, and that's what allows us to support all the different compute environments. But one of the things that's interesting is what is currently our largest deployment at a Fortune class company. We introduced Docker to them. It's a bare metal Linux application. It's consuming us as storage. And so they actually are using Docker. So we use Docker inside the platform as one of the ways that we can deploy. And we can talk about that in the whiteboard session. So another thing I've talked about is the ability to run, so we're software, and you can run us on your own hardware on premise, or you can run us as an instance in a cloud. We run on the compute side of a cloud. And so what we can do is then span a logical cluster across cloud and on-prem, making it sort of implicitly hybrid. And then inside the platform, you could set a DR policy against that and say, for this particular volume, or for this particular element where I'm a virtual disk where I've got my data, I want 1 copy in San Francisco, 1 copy in Denver, and 1 copy in AWS, right? And the system will adhere to that and make sure that the data protection capabilities are not only making sure the data is spread out among the cluster, but are actually spread out among unique sites. And so the fact that it's built into the cloud has been an early driver for some customer interest in terms of adding DR as a cloud tier.
Although presumably when you're running on a cloud, you've got all the existing storage software and capabilities of the cloud, and you can't escape those, so you have to work with them and their limitations.
Yes and no. And I'll tell you what I mean when I say that.
Okay.
I'm going to hijack Rob for a second here. So when you look at a typical box on which we run, there are a bunch of SATA disks in them, right, which we treat as JBODs and we manage, right? Now you can virtualize those JBODs, right? So when you run on AWS, for instance, those JBODs are virtualized via EBS volumes, right? So at that point, you're running on top of EBS volumes, right? Now, yes, the no part is, what you said about whatever deficiency the underlying infrastructure over there has, you carry it with you. But you also bring a lot of advantages in the sense that if there is no cross-zone or cross-region replication, I confuse the terminology, but you can punt that onto our system and we can take care of that.
Right, okay.
Right.
Okay. Two more. So another thing is everything in the platform is it's thinly provisioned. It's a very rich metadata architecture, and so just like in Amazon, it's a few clicks, and we'll actually demonstrate this. Things can be batch provisioned. We could create thousands of volumes of virtual disks in seconds. And then finally, I've talked a lot about the storage capabilities. It's probably best left for the demo, and I can certainly rattle them off if you want, but a lot of the more advanced features you'd expect in a storage platform, which we feel lend themselves very well for some of the new applications that are coming out. So for example, if you were to run Hadoop on us as a platform and you're doing the default three-way replication in HDFS, you'd want to turn that off. You'd want to turn replication off for us so that you're not getting 9x, right? We do three-way by default. Our replication is actually tunable, anywhere from 1 to 6 copies. And Avinash will get into a copy to us doesn't mean we take a 1 gig disk and spread 1 gig out all over. We actually do it at a more granular level. But the ability to do all of these capabilities at a very granular level is important, especially since we have customers that are deploying multiple distributions of Hadoop, and the developers get to call the shots. And so in some instances, they may not want the data compressed or deduped, but they do want replication on or off. All those choices can be made on a per, in this case, Hadoop basis. And more importantly, we can still get, if we want, the global dedupe across the whole data set. So there are some kind of unique things that we can do when facing certain applications because of the granularity at which we can turn things on or off. I'll get into this a little bit more in the next. So here's the very slide that I was talking about. So these are the 4 areas that we're targeting. So I think there was a fair question asked. There's also a fair corollary to that question, which is what don't you do well, right? And we can take a stab at that as well. So right off the bat, one of the things that makes sense is to use us for highly virtualized environments where you're basically looking for a virtual SAN that's just a lot more scalable and has some of the provisioning capabilities you expect more on the cloud side. What differentiates that from the next use case over, private cloud, which would be driven a lot by OpenStack or something like that, is at that point, our entire platform can be, is API driven, right? So we have a web GUI, which we'll show you to demonstrate the product. We have a CLI as you'd expect, but everything in the platform can be configured via API. So when customers are moving into the cloud era, they don't even go into the user interfaces. They're usually scripting this all and automating. We're plugging into whatever service catalog and orchestration framework they've got. And it's not just like a subset of the features are driven by APIs. You can pull out data. And so one thing that we see a lot is the emergence of these data-aware storage platforms where a lot of the analytics are based on the platform itself. We've had some customers come to us and say it's kind of like having to adopt in a religion with your product, though. We already have a data visualization or an analytics strategy. To be able to pull that out via APIs and visualize it themselves is easier for them than forcing them to log on and do that native, usually for an interface that was more designed for an IT admin anyway, right? So we want to make sure that we plug into that capability as opposed to force a new language or a new approach onto customers. And that's one area. On the big data front, we've talked about Hadoop. You could also think of NoSQL platforms like Cassandra. All those are perfectly logical things to put on top of us. The driver here from a customer perspective is if you have multiple NoSQL flavors, if you have multiple Hadoop flavors, and they're managing their own storage, yes, that's elastic scale-out storage on commodity infrastructure, virtual, all that stuff we've talked about. The difference is you've now got giant islands of this stuff, and usually gets thrown over the transom to the IT organization to scale and manage. And there's no commonality, there's different operational procedures. So to have what we call the human latency of doing things differently and of admins, getting that out of the equation, having one platform that can be automated, and then you just simply configure or provision it as necessary for all these different big data applications, is something where we've seen a lot of push and pull. And again, Hadoop being an area where we've already seen some traction. Finally, the last one I'll just talk about quickly, because I know it's not as relevant for this audience, is on the backup and DR side. Because we can run across sites and clouds, we're a natural target for a backup application, or if you're trying to take something like some files and just make sure they're distributed and have higher protection across sites. So that's a capability for us. It's also usually the low-risk place that people want to get started, right? Because we're not going to put you in a tier 1 use case right off the bat. Right, so we don't see a lot of companies wanting to. And then certainly we don't see tier 0. Everybody defines tiers differently. But if you're in the storage world and you're thinking extreme high performance and you're going after an all-flash array, that's something where you wouldn't turn to us right off the bat. Right, we can use flash assets and we can help give dedicated consistent performance for certain workloads, but we're not a tightly coupled system like those guys are.
So, just to clarify, so you're saying that you've got existing customers today who are doing some of these things?
We have existing customers today that do all 4 of those buckets. Okay.
Yes.
And that was a conscientious decision we made right up front to be as broad-based as we possibly could. I mean, at least pick 2 or 3 use cases to go after rather than just pick one. Because what I've learned is, and I have no personal experience, but what I've observed is that you pick one use case and try to kind of align yourself to that. Pretty soon you get perceived as a niche play. This is the last thing that I want happening. So that was the goal. And even if you look at the customers, which I'm sure, I don't mean to hijack, but the customers are also across different verticals. And that was also a very conscientious decision right up front.
So, and it does seem that you've made choices to play well with others to use, so you're able to connect in using S3, so block, file, both kinds of block, object store, so pretty much any interface you can support applications that use those, which I think is smart in enterprise, because they'll have a bit of everything. It won't be all S3, they've still got fiber channel. That requires you to have quite a broad set of offerings, though. Are you spreading resources thin to do that, or is the way that you've built this thing means that you can do all of that because
it's the latter.
It's not a big deal?
It's the latter. Okay. One of the things that we are seeing in definitely in the larger enterprises is, they have a slew of solutions perhaps for block, right? A different vendor for, say, file-based solutions, right? And they're trying to figure out what their object story should be, right? So where we have found maximum traction is when we go and say, hey, here is one platform, use it however you want. You've completely cut down your operational overhead because you don't need to train people in different products and figure out how to work with different vendors.
Let me go a little bit. Let me just familiarize you with the different kind of components that are inside the platform itself, and then I'll have one diagram. So as I mentioned, there's 2 software components. There's what we call the storage service. That's what actually deploys on an x86 or ARM service, or you run it as an instance in the cloud. That's where all the heavy lifting, it's all the intelligence. It's where the actual cluster itself is. We also have this lightweight capability called storage proxy. You deploy one per physical host that needs to consume us as a platform, right? So this is what you would run on your Hadoop application servers, for example. This thing's goal in life is very, very simple. It only has 2 functions. One is it's basically a glorified protocol converter. Northbound, if you will, it speaks whatever the application or OS is expecting. Southbound, it speaks our own cluster protocol, right? And so its job is to make sure you don't have to rewrite applications or rewrite environments to consume this type of platform. The other thing, and by the way, it's basically a stateless as a result. So it's a very lightweight process. It is not resource intensive. The other thing that the proxy does is it can take advantage of flash assets at that compute tier and do some server-side caching. So there's things that we can do to boost performance as well. So it's basically a write-through read cache that we can do at that layer.
So does that mean that if I've got, say, a whole bunch of data sitting in a database, this is going to be a tricky thing to answer. Now, if I've got a whole bunch of data sitting on one system and then I put in a new system because I want to do some analytics on some data that I've got sitting there, but normally that would mean I'd have to do ETL and transfer it from one place to another. Would I be able to use this to help with that? But if it's sitting in a database, the answer is no. I think I've answered my own question, so.
Define database.
Yeah. Well, if it was flat files, for
That's
example.
what I mean,
If I had
yeah.
flat file stuff sitting around, which we were talking about before, it would just or JSON,
Yeah.
sitting somewhere.
Mention a native protocol for your data. The proxy is just a gateway for different, but it's possible reach your native protocol.
Yes, yes you can. So
Site you have a
Yes, you
API
can.
also for this.
yes, so actually you bring up a good point. You guys are way ahead of the entire schedule. So
Okay.
The
okay, we can skip
Hedvig
forward.
storage proxy, right? Its job in life is to northbound masquerade as an iSCSI target or as an NFS server, right? And in the future, SMB, right? So what it's actually doing is, and southbound it talks APIs that we expose, right? So one could program against those same APIs and achieve
Can
what you want to do.
use you can build your application using this kind of API.
Now that's cool,
Is
because that would
it's
mean
not
that I could
only
do...
for management, is for data access.
Oh, I could
It's
do
for everything,
Distributed data
everything,
access.
everything.
I could do some really dangerous things with that.
Okay, so those are the two software components. There's an abstraction inside the platform called the virtual disk. Avinash will go into this in much more, but it's basically how we expose the platform to be consumed as storage. What I'm just going to show here is a typical workflow. Imagine you have a mixed environment. Here I'm showing VMs, but this could be a bare metal server. It could be a Hadoop instance, something like that. The first thing you do is you create this virtual disk. You carve it up and say, I want a terabyte, I want a gigabyte, whatever, 100 gigs. You create it and you assign all the policies that you want associated with it. Its DR policy, all the different features.
Is that more like a LUN, or is that like an actual disk that's going to be presented to a workload?
Well, the question was just, so the virtual disk, you assign it its properties. If you make it a block device, then it gets exposed as a LUN. If you make it an NFS, it'll be exposed as an NFS export, so on and so forth. One thing I'm showing here.
You could do both.
We can do both.
Same box, right?
Not for the same
Simultaneously.
virtual disk, for two separate virtual disks, of course.
Oh, okay.
And when Suresh gets into the demo, it'll be very clear. It's really simple to do it.
Yep. One thing I just show here is if you're consuming us via object interfaces, you don't necessarily need the proxy. Again, we talked about earlier, you can program directly against the cluster. So we speak those APIs, if you will. So, and by the way, for simplicity's sake, this thing can be iSCSI or NFS. So this software, the proxy, shows up as everything, so you don't have to deploy multiple instances of it. I'm just showing for simplicity's sake that pretend this one's being consumed as block, therefore it's iSCSI, this one's being consumed as file, therefore NFS.
Does that end up being a single point of failure if the proxy goes?
No, it does not.
Wrong?
When I get to the whiteboard, I'll walk you through why it is not.
Is that the same virtual disk? Or could it be the same virtual disk?
No, you have to think of it as a virtual disk per VM. That's the granularity at which you can operate.
Per one of these, or no? Per.
So your question was, is it one virtual disk that is given to everybody? Is that your question?
Or can I access the same virtual disk via multiple protocols? So
Yes.
if it's block and NFS, probably doesn't make a lot of sense. But if it's, say, I don't know, S3 and NFS?
No, S3, that's it. We don't allow two different protocols to work with the same vDisk.
Okay, can't be done. Yeah.
But
Okay,
the other point you were making was that it's a one volume per workload. You don't carve out a big VMDK or a
I mean,
big
you could do-
VMFS and
You
put
could do
both
that
the
too,
VMDKs on.
but you could do that too. So for example, if you were to go with the example that you just brought up, you create one volume, present it to n number of those proxies, right? But when you start putting VMDKs on top of them, internally the system will cheat and create a virtual disk or VMDK.
Well, even VMware's going that direction. So
Yes.
yeah. Okay.
But it's all hidden from you though.
Nice.
Okay, so the traffic then goes down, and this isn't a single point of failure. Don't think the virtual disk is just a logical abstraction unit. It's not an actual process. So now at this point, the storage proxies are sending data down. It's spread among the cluster based on policy. Avinash will get into more detail on that. The only thing I was just going to say or point out here is that we can actually the cluster itself takes care of auto healing and balancing and doing some of the things. So one of the design principles here is minimal human intervention on the cluster side. You shouldn't have to be an expert in distributed systems to operate this thing. The intelligence was built into the software in terms of how it can recover from anything from a disk failing to a node failing to a data center failing, right? Depending on how you've written your DR policies. So to be able to take a data set and spread it out and have it adhere to all of that. So that's the quick visual. Avinash will go through it at a more granular level on the whiteboard. So I just have a few things left, and then I will get off and we'll get on to the good stuff. So a little bit about how we're different. So in essence, if I had to boil it down, the distributed storage platform it's the way the distributed systems engine is built that ultimately makes us different. Right? We can get into it at a much more granular technical level, but if you think about it, we would argue that how the system handles all that, the intelligence, the algorithms, the way it survives failures, the way it scales, all of that is in essence what is most unique about our platform. We hide a lot of that so that the user doesn't have to think about it, but it's what lends us well to these new elastic workloads, to things like big data, more so than traditional storage platforms. So there are, if we really want to get into it, some patented capabilities that make up that distributed engine, but we would be getting way down into storage land and way into distributed systems land. So we can certainly send this. We have technical white papers. We have all sorts of ways of getting more detail. But if I had to give you a technical answer in terms of what makes us different, it's this engine. It's the way we handle the data. If you think about us relative to a lot of the kinds of storage offerings that are out there, there's basically, and this is my sort of super simple way, is you're basically deciding between two legs of a stool, right? You're either favoring things like flexibility because it's software and can get deployed in multiple ways, or you're thinking about features. And I have to have all the fancy things my IT ops teams and my storage teams have come to appreciate. Or I'm thinking about all those protocols because of the next generation of applications coming down the pike. We think there's an opportunity to actually balance the three. So it's no surprise, my marketing credentials would be revoked if I didn't put us at the center. Right? So the ability to blend those, right? And when I think of the current software-defined storage, it is a lot of the object storage guys, because there's also all the virtual SAN. So we see those as, they're both in software, but in some way, shape, or form, they'll have different, I don't want to say compromises, but different decisions. It's very difficult for them to do some of the capabilities they did. Again, because the quality of that distributed engine, to do this stuff at scale for large data sets is something that requires that type of engine. And this is my very last slide in terms of a lot of the things that kind of just summarize it, right? If you think of why customers are choosing us, it's either because it's the complete platform and it allows them to go down to a much simpler operational model. It's the OpEx that they're trying to optimize, not the CapEx. I liken software-defined storage a lot to like cloud in the beginning. Everybody thinks it's about saving money. It can be, but it's not. It's actually more about, I hate the word agility, but it's more about doing things that in a simpler operational manner than it is. If you save money along the way, great, but you have to architect the system to save money. Because of the environment, so we have customers where they'll go in and, one customer, a bare metal Linux application was the first thing, Hadoop was the second thing. Then they threw a SQL database on top. 3 completely different workloads, all serviced by the same underlying platform, where you're basically just incrementally adding the horsepower to the cluster to handle those, and then configuring that cluster with the properties that data set or workload needs. We talked a lot about the granularity. You'll see more about this, but it's the ability to turn things off and on. And it's not even because of, I'm trying to run 3 instances of Hadoop. It's also because needs change very quickly over time, right? So it can take days, weeks, or months. According to Forrester, 58% of companies still take days, weeks, or months to provision new storage assets. Well, that's kind of a bummer when you're trying to do things in the analytics space and the storage is being measured in hours, days, or weeks and not minutes. And then finally, the ability to add cloud. One of the things we talked about how you might add cloud. We also have customers that were born in the cloud and are thinking about how they can add on-premise, because the economics of operating a cloud eventually can become quite crippling. So hybrid is not a one-way street. It can be companies that want to add cloud. It can be companies that want to add on-prem. But the ability to have a single platform that can span your data across that.